Awesome. Cool. So this is the starting of Fastbook session, and this is the second session. We had a first one last week. This is the second session, and we're going to start looking at chapter 1. I'm excited to have you. I'm excited to have everybody here, and I mean, this is a journey where, as Jeremy mentioned last week, is like we want to life will happen along the side, and what we want to do is we want to commit ourselves for the next 20 weeks. And conscious of time as well, like we have. I'm going to try and cover a chapter every week, spending 60 minutes per chapter. But sometimes when we go deeper and deeper into the book increases in complexity very fast. It's like an exponential curve. Um, and something what we want to do is we want to stay as a group. Like we want to come back every week. We want to be there for each other when the complexity increases, because I think that's where the reward is. The reward comes when we face a challenge and then we don't give up and we keep asking questions, we keep answering questions, and that's where the major benefit comes. So that's one thing that I want to start with saying is like we want to come back every week, and we want to make sure that we finish strong. Okay, so for the agenda for today, we're going to start by looking at the first chapter. We're going to start with a deep learning journey. There's a few topics that we will look into today. I'll spend the most time towards the later end, like 1.6 is where I'll spend the most time, your first model. And if we get to 1.8, that's where I'll spend my most time as well. The other things are, the idea for me is to give enough information that you can then go back and like give you enough information for you to go back and read the chapter. And if you have any questions, and if you have, you have any problems, you can reach out to us. And I'll be there to answer. So one thing I did say last week as well, I do take it as my personal responsibility to make sure that we all get past the line, and to make sure that we all learn and we all benefit from these Fastbook reading sessions, and I still live by it. So don't be afraid to reach out to me. Don't be afraid. I'll be investing a lot of my time in doing this, and hopefully we can all benefit towards the end. So yeah, so that's the idea. That's the agenda for today. If you haven't joined the 1db.me/Slack, now is a good time to do so. So I'm just going to paste this in. I've just shared this link in Zoom chat as well. We're going to do something very similar as last time. We're going to use the report. We're going to for questions. But if you haven't joined our Weights and Biases Slack, I think this is a good time, because you go join in there and you go to the Fastbook channel. That's where we can ask each other quick questions. Oh, sorry. I just saw somebody mentioned that my mic could be closed. Is this better? Okay, awesome. Apologies about that. Cool. I'm not constantly monitoring the chat though, so if there's anything, you can just mention the chat, and Angelica, you can reach out to me. I think that will be easier for us in the next 60 minutes. One thing I do want to stress a lot when we're beginning this journey is I want you to ask a lot of questions. It's just between us, and I want you to think of us as everybody in this group as a safe group. I want you to not be afraid of asking any question. There's no question as a silly question. And going forward, what we want to do is we want to ask lots and lots of questions, because I've seen from personal experience that sometimes what we do is when we're stuck, we give up. And one of the easiest ways to get unstuck is to ask the question, because somebody else might have the answer to a question that we're stuck at. And if you spend enough time on it, when I say enough time, I think if you believe that this is something that you need help with, don't be afraid, and ask your question right away. And something you'll notice with the Fast AI community is everybody here is very helpful. And you'll people will make a genuine effort to try and find answers for the questions that you do ask. So please ask lots of questions. The next thing I want to say is answer questions. Answer questions and lots of questions. So if you're somebody who has an answer to a question that somebody has already asked, be there to answer it for them. I might not be there or might not be around. It might be my nighttime or it might be very early morning. But if you're there and you see someone asking a question and you have the answer to it, I want you to think that you want to spend that time in answering that question. And the reason, and one example that I like to give here is that of Zach. Zach has spent over 33 days of reading time in the FastAI forums. If you haven't looked at the FastAI forums, let me bring them up quickly. So forums.fast.ai, we briefly mentioned this and shared this last time as well. But forums.fast.ai are a place where there's lots of activities happening. There's lots of threads in forums.fast.ai. And something that Zach is really good at is like he spent a lot of time answering questions and discussing questions. And it's really helpful when you answer questions because you get a deeper understanding of things as you go. So something I really want to stress as well is if you try and answer somebody else's question, in the end, you might benefit with a deeper understanding of the thing that you're answering question of. Let me also quickly show up Slack, where we're going to be discussing these questions. So if you go in Slack, this is called Weights and Biases Forum. To join it, the easiest way is to go to 1db.me/Slack. Sorry, can you guys see my screen and you can see Slack, right? Awesome. Cool. So then this is where in the Weights and Biases Slack, this is where you want to go and you want to ask your questions or answer your questions. So if you head over to the Fastbook channel, I've seen that there's already a question here and I'm making an effort to answer all of them. There's lots of other things. There's sometimes announcements and there's lots of activity happening in this Fastbook. You want to join this channel, you want to be a part of it. Next thing I do want to mention, if you go to 1db.me/fc, I'll paste this in the channel as well. So if you go to 1db.me/fc, and if you have a quick question on this, there's ways you want to reach out to me. If you don't know of this place, then go to 1db.me/fc and then head over to the forums. In the forums, you'll see lots of other cool stuff. So we'll be using a mix, for Weights and Biases Slack. We'll be using a mix of Weights and Biases forums, or even the FastAI forums. Like for me, either or is equally good as long as I get tagged or as long as I know that you're asking a question. So we can get there and answer those questions for you. Today specifically, we are going to be going to this, like we did last time, we're going to be going to this Weights and Biases report because we're also live on YouTube. So it's very hard for me to look at the Zoom chat. It's very hard for me to look at the YouTube chat. So this is a central place where if you write a comment and which I'm writing test, it is live. So towards the end, we're going to try and answer these questions, whichever ones they may be over here. So I'll paste this. Oh, so by the way, Angelica has already shared in the Zoom chat. The easiest way to get here is to type this 1db.me/fastbook1. And every week going forward, this will go from Fastbook week 1 to Fastbook week 2, week 3, and so on. Cool. So we want to ask lots of questions. We want to answer lots of questions. We make progress as a group. What I mean by that is we're not here to judge anybody. We're not here to laugh at anybody. We're not here to feel like, oh, this guy doesn't know this or this person doesn't know that. No, instead, we're going to be, okay, well, if you don't know something, I have 2 years of experience in doing this, and I'm going to make my best effort to help you. Because the reason why I say this and the reason why this is crucial, in my opinion, to make progress as a group, most of the people in Fastbook that are here today have told me that they started their journey by themselves alone and they gave up on that journey. And the sole reason for that was they hit a roadblock that they could not cross by themselves. But that's the difference in doing this alone at home. And this is the difference of doing this as a group. So if we meet as a group for the next 20 weeks, then we make sure that if you have a question, there might be somebody who's really good at stats who'll be able to answer that question. And that stats person who answered your question might have a question about programming, which you're good at, so you can answer that question. So see, that's the whole point of making progress as a group. One thing I really want to try, and one thing I'll make my best efforts towards, is we don't leave anybody behind. So as in, what I mean by that is we make sure that we finish and we make, because that's where the progress will be. Like the progress, you won't notice the progress in the first session today, but you'll notice the progress after 10 weeks, because that's where week on week and week by week, we'll learn new and new things. And that's where the progress will come. And also week by week, things will get more and more difficult. So we want to stick to people around us, and we want to have this really good community, and we want to make sure that we ask questions and we answer questions. With that being said, from this point on, you will be required to write and read code. If you haven't already seen this Fastbook setup instructions forum post that I created, the easiest way to get there would be, again, if you go to 1db.me/fc and you go to and you head over to the forum. Very soon, we're going to have a Fastbook tag here, so it will make things easier. But you can search Fastbook. That will bring up everything that you need. And here it is, Fastbook setup instructions. This is something where I have pointed out the list. There's a reading plan on what we're going to spend and how much time we're going to spend every week, which topics we're going to cover. We'll be joined by Zach, we'll be joined by Tanish, we'll be joined by Sayam. I believe they're here today as well. And this is how roughly the plan looks like. For me, the stress and the one thing that I really care about is making sure that we understand things. Even if we take, instead of 25 weeks, if we take 30 weeks, that's fine with me. But for me, what's not fine is that we leave a topic. So we don't want to leave something that could be important and then still try to catch up with the timeline. So if instead of 25 weeks, it takes 27, that's fine. And I'm going to try and make the best effort to complete one chapter a week. So we'll see how that goes. So here it is. This is the important bit. When you go back today, you will be required to do this. So how do you set up? Do I need a GPU? Recently, Jeremy on his YouTube channel. So if I go to YouTube and I search for Jeremy, you will be able to find that he has a lesson 0 practical deep learning for coders, fast.ai. And I've posted that link in this forum post as well. So let me quickly post this in the chat as well. So if you can go to this page, you'll be able to find that there is this YouTube video. In this video, Jeremy shares information on how you can set up for doing the FastAI course. You might have a question about, do I need a GPU? There's lots of free options. One of them that I've found to be the most important, to be the easiest, is using Google Colab. So if I just click here, there's a just click here and you can select any chapter. If I click here, as long as you have a Google account, this is really easy to start. So I just clicked on it. It opens something like this, and I can go towards, because we're looking at the first chapter today. So I can click on 01 intro. I can go to runtime. I click on change runtime type. I select GPU. I click save, and that's it. I'm good to go. Now I can actually run my cell. That's it. And then I can import everything and you'll be able to run code in here. Just wanted to share that. So that's one of the easiest and fastest ways to get started. It requires me to authenticate, which I can do later. But that's one of the easiest ways to get started. In that video and on the FastAI website, there's also lots of other options. So if you're somebody who has a background in using AWS, Azure, or Jarvis Labs, or even Data Crunch, so these are other options that are mentioned here, and I've already have this link posted in that forum post, but let me quickly share it here as well. Okay, so there's lots of options that are already there on the Fast AI website. I do recommend that if you're new to this, don't be scared. Go back, take your time, watch Jeremy's video, and then set up, make sure that you can run the first notebook. If you can't, reach out to us on the Weights and Biases forums, the forums.fastai or Slack, anywhere is fine. Okay, with that being said, that was the early instructions. Now we're going to start with all the topics that are covered in the first chapter. Most particularly, we're going to be spending time in training our first model today. You heard it right. We're going to, within the next 30 minutes, we would have trained our first image classification model. And we'll also spend some time looking at the validation sets and the test sets. So I'm actually using AWS to set things up, and I'm running things on, I'm using GCP and I'm running things in Jupyter. If you haven't seen something like this, this environment is called a Jupyter Notebook. Again, in that video that Jeremy has shared already, you'll find information about what a Jupyter Notebook is. So we'll get started, but very quickly, if anybody has any questions, let me just go to that. Let me just go here and let me just double check if anybody has any questions so far. Oh, there's a few questions. Okay, let's take, what time is it now? Let's take 3 minutes and let me see how many efforts I can. How important is understanding of ML in order to get started with deep learning? It's not important at all. Like everything we're gonna do in this book, like you're not required. The expectation is that you can understand code. Apart from that, we're here and that's the journey. We're going to start with exactly like one of the things that we're going to look at today is what is machine learning and what is deep learning. So it's not a requirement at all. Thanks, Kevin. Put effort in your questions too. Providing source code that reproduces your error is the top way to get an answer. That's really helpful. I think what Kevin is mentioning here, like if you're trying to run code and you get stuck, please copy paste the whole thing and don't like just go, oh, something like this is not working, because then it's easier for us or for the other person on the other side to let you know exactly how to solve that problem. And something I want to say is like, something that has really helped me in my career has been to be visible in the public eye. So I think not being shy of asking questions, not being shy of writing blog posts, not being shy of being active on Twitter is something that's rather a bigger benefit than not asking questions. Because if I'm not embarrassed to ask a question, but I'm stuck at that question, and I ask it on Twitter publicly, then somebody is going to give me the answer, and that's a bigger benefit than not asking a question. And one thing I do want to stress as well from this point on is what we want to do is we also want to stress and focus on writing lots of blog posts, because that's something that Jeremy has always said, that writing blog posts is really, really helpful. And I can say that from my personal experience as well. When you share your resume with people, only some people are going to see it when you apply for a job. But your blog post actually gets seen by a lot more people. It could be Kaggle kernels, it could be lots of things. So feel free to ask questions openly and don't be afraid at all. Nobody's going to judge you. And I promise that any question that I can answer, I will find the time to answer those questions. Why have you chosen to make the sessions without audio or video from the user? It makes me think that this group is more focused on the content versus, is that a fair statement? Do you think there's value? Oh, absolutely. There's no such thing as, there's no point in like having you guys as without a audio or video. It's just a it's just a number, because in Zoom you have other things. Like in Zoom you can have a meeting to only a certain number of people, and then you have to go switch to a webinar. So that's only the technical detail. For me, there's no such thing as we can't have audio from you guys. In fact, I would love to meet you guys. So it's just, let me go back and bring this up with the events team, and if it is possible for 200 or 300 or 500 members to have audio and video on at the same time, then let's see. But otherwise, one thing that's going to happen is that going forward, we're going to form lots of small study groups, which are more concentrated and where we can have audio and video on at the same time. But if you have a question, just raise your hand and we can allow you to ask that question. How can I set up notifications for the Fastbook tag? That's something I'm not sure if that's a feature in yet, but Angelica, if there's something that you might know about this, you can please feel free to answer this one. Okay, yes, there's going to be recordings about this session, and Discord. We're not using Discord. We're using Slack. Is it only for discussions? It's either or. There's no point of saying like Slack is only for this, or the posts aren't. Do we really need a GPU? No, Google Cloud Platform provides it for free, so you don't need it. Will you recommend setting up locally? These are all questions I will answer now, because I'm also conscious of time. So let's kick off. Okay. First things first. I want to give you enough context that you can then go back and you can read the whole lesson 1 intro, and you'll get all of it. That's my aim today. So the first thing is, deep learning is for everyone. If you're someone who comes from a background who feels like, oh, I don't know math, I don't have lots of data, or I don't have expensive computers, I don't have GPUs. Something that this book starts with saying is that deep learning is for everyone. And when they say deep learning is for everyone, deep learning is also around everywhere. So deep learning here's a list of like many different tasks that deep learning that you'll see deep learning today. So if you're writing like a Gmail, or deep learning's everywhere now. If you facial recognition, self-driving cars, using when you're typing an email, spam or not, or there's all these different things. Even in medicine, you can have like X-ray, CDs. So my previous workplace was exactly this. Like we were working on X-ray and CD scans, and we're trying to classify them into different things. You can even generate images. So there's examples that I will showcase later down as we go into the Fastbook, that you can actually ask a deep learning model to then, if you say that you create an image of something of an avocado that looks like a chair, it is actually going to take that input and can generate that image for you. It can be used to play games. We've seen AlphaGo, that sort of that deep learning is used these days to do all of these things that weren't possible 10 years ago, but now deep learning is everywhere. I'm going to skip over this part, which provides a brief history about neural networks. It's basically about it's basically about Warren McCullough. He was a neuro physiologist, and it just shares like this story of how neural networks came about, like the name and how it is related to neurons, which should be okay for you guys to go back and read. It's not a lot. It's only like 3-4 paragraphs. The main thing that's important here is like this book was written by Sylvain and Jeremy Howard. They are going to be our guides on this journey. Who am I? I'm someone who's on this journey with you guys as well, but as someone who's spent like 2 or 3 years just spending time with the Fast AI courses. So what we're going to do is we're going to go through this book as a group. And Jeremy, it would be really helpful to read about all of this about Jeremy. I think we all met him last week. But Jeremy has he's someone who doesn't come from a PhD background, but he's someone who's been using and teaching machine learning for around 30 years. So while he doesn't have a PhD, he's someone who comes from a very practical and a coding oriented mindset. And he started using neural networks 25 years ago. And the other thing, Sylvain, on the other hand, has a formal technical education, and he's in fact written 10 math textbooks. And Sylvain is now working at Hugging Face. So unlike Jeremy, he hasn't spent many years coding and applying machine learning algorithms. He only recently came to the machine learning world. So you get a mix. You get a mixed batch of experience and math between Jeremy and Sylvain, and that's why this book has been so popular and so helpful with people starting out. Because if you're someone who doesn't have a PhD, who doesn't come from a math background, then it's still really easy for you to understand. And if you are someone who's coming from a mathematics or a statistical background, then again, Sylvain takes care of, like, you'll understand a lot of things that where Sylvain comes from. So it's in this way, this book is really balanced and definitely one of my favorite ones to get started with deep learning. Next thing I want to stress out is how to learn deep learning. This is something really crucial between us. So one thing you want to do is you want to, the way this book is designed is on a Harvard professor's theory by David Perkins. Basically, what he says is, when children go and they try to learn football, you don't actually teach them what pressure is. You don't teach them what a parabola is. You don't teach them, oh, this is the force at which if you hit this football, that's when how it's going to go. You give them the football and you let people play, and you let children play, and that's how they learn how to play football. Same goes with other sports, and it's completely the opposite of what's been happening in the academic world. Is when we, at least when I started, we would first taught matrices, we were first taught linear algebra, we were first taught arrays, we were first taught vectors, and we were first taught all these ground up, like all these base things that I didn't know how to apply. And the reason why I didn't do very well at that was because I didn't have a motivation to, like, okay, how are matrices going to be important in my life? Like, why do I even need to learn these things? And this is how this book is different from a lot of other ones. Is the way they've designed this book is you'll start with training an image classifier first. In fact, we're going to do it today. And then you're going to learn slowly and slowly about things like what exactly is an image classifier, what exactly is a deep learning model, or what exactly are the other things. So we're going down that football approach where we as people are going to learn how to play football first, and then we're going to get better and better at all these other things, and we're going to go deeper and deeper into the subject. So it's a very top-down approach. And this is one that's definitely recommended in this book. Is like, you want to do lots of experiments, you want to do lots of code, you want to try and go back and, like, first fiddle with things of, okay, this is the input to this thing, this is the output to this thing. So this is how we're going to try, is like, we're going to do lots and lots of experiments. And this is the commitment of this book, is like, they're going to teach us the whole game, as in not just give us the football, but actually they're going to teach us the whole set. Like, when I started with this book, the first thing you learn is, okay, you learn how to do an image classifier using FastAI, but after some time, you actually learn what a ResNet is, you actually learn what a batch norm is, you actually learn all these different concepts that you wouldn't have imagined that, okay, by the 20th chapter, you're learning all of these things. And today, I also started with the same Fastbook lesson 1. And after some time, when you actually get all these pieces together and you go deeper and deeper into subjects, you can then pick up a research paper and you can still understand it very well. So that's the commitment here. And always teaching through examples. So examples are going to be key. It's going to be simple, and it's going to remove barriers. So deep learning has no barriers. It's going to be, in fact, what we're going to see in this book is, like, anybody can do deep learning. The next thing is FastAI. I'm going to touch on the software side of things, like PyTorch, FastAI, and Jupyter. So PyTorch is a library. If you don't know what a library is, or you're new to coding, a library is basically something that has a set of, like, it's basically something that's more lower level. So it has, if you want to do something like say you want to add two matrices together, NumPy is a library that you can call a lower level function on, and you can then call that specific thing, that specific part in that library to do those things. So PyTorch, because we do expect that you have a 1 year of coding uh, and you're good at Python. So then PyTorch came out in 2017. And before actually using PyTorch as the base library for FastAI, Jeremy and Sylvain actually spent thousands of hours trying different things, experimenting with different things, and then finally making sure that they're using this library for FastAI. So PyTorch is the underneath layer on top of which FastAI is built. And PyTorch has since then become the world's fastest growing deep learning library. And it's already used in most research papers. In fact, lots of research papers that I read today already have code provided in PyTorch. So it's really easy. It's really helpful that if you know PyTorch and if you know FastAI, so as we go deeper and deeper, not only are we going to pick up more and more of FastAI, we're actually going to also learn more and more about PyTorch. And that's a skill that I find really, really helpful, because in today's world, if I'm actually reading a research paper and there's code in PyTorch, then all these things that I've learned over time really come in helpful. And this book will cover the second version of the FastAI library. Something I do want to stress, like we don't want to like something that's important is the ability to learn new things. And I've definitely can say that from my personal experience as well. PyTorch may be relevant today, but in 10 years down the line, you never know if JAX will come up or Julia will take over, or there's all these different libraries that keep coming over the years, and it's only going to get more and more. So people are only as more and more people are getting into deep learning, they're going to bring their ideas and they're going to bring their libraries and they're going to bring all these different ways of coding over time. So it's something that you should also have this mindset, is that I don't want to commit myself to just the one library because it might be outdated 10 years from now. But rather what I want to focus on is learning the basics, like learning then this book will teach us the basics, like, okay, what is deep learning? What is a deep learning model? What is a ResNet? What is a batch norm? Because if you learn the basics, then you can apply it to any library, be it TensorFlow, be it PyTorch, or any other library. So that's the most important thing. Another thing we want to be really good at is writing code and experimenting. And we're going to do lots and lots of that. Over time, we're going to spend lots of time writing code and we're going to spend lots of time writing experiments. In fact, I do plan that we form groups and we work on projects, interesting projects that could then go on your resume, or just these experiments that we do between us as a group, or even research. But that all comes later. So as I've said, it's a marathon and it's not a sprint. So we're going to take things slowly, but we're going to take things consistently and we're going to improve over time. Cool. That was it. Like that's just the basic introduction. And now we're ready to start with training our first image classifier that can recognize dogs and cats with almost 100% accuracy. So when you get to this point, the first thing is getting a GPU deep learning server. So you should be able to run this code in your own machines. I've already mentioned a few in this FastAI setup, but you can do it here and also watch Jeremy's lesson 0. But if you have any questions, yeah, feel free to reach out. One thing I also do want to mention is that the Fastbook has 2 versions. So there's all of these notebooks over here, but there's also a clean version. The clean version is just headings and it's just code. So it's not there. It doesn't have any of the pros like this version does. So there's only these 2 different versions. So something that I found really helpful and is a really good way to learn deep learning using this book is you spend time, you go back. I'm giving you enough context. I'm giving you enough things for you to spend time and go back and read about this whole chapter. And then once you read this whole chapter of the book this week, if you have any questions, you keep asking those questions. But once you've read the whole chapter, go back here, go to the clean version, and then see if this code, and you can actually make sense of, okay, this is why we're running this code, or this is what's happening in this. So it makes sense if you can summarize that whole thing. And towards the end, something that you'll find really helpful is towards the end, you'll see this questionnaire. So this questionnaire is just 20 questions, about 15, 20 questions on the whole chapter that we will read. And those 15, 20 questions is like, what is a GPU? Or just basic questions that are there, that are going to be there in this whole chapter. And if there's any question that you ever get stuck with, or we can actually discuss these questions on these going forward like this. We can have Fastbook week 1 question discussion. We can have Fastbook week 2 question discussion, and we can discuss all these different questions, but feel free to ask me anytime. So as I said, there's 2 folders. One is the clean and one is the unclean. Jupyter Notebooks has 2 modes. There's an edit mode and there's a command mode. So if I double click on this, I'm in the edit mode because I can then type things. And if I press escape, I'm in the command mode. So pressing Control Enter and then I'm pressing up and down is something I'm in the command mode. If I press escape and I press B, because I'm in the command mode, it will create a new cell. So there's these small things. Oh, I just pressed escape and DD to actually delete this line of Jupyter Notebook. So it will really help if you spend time just this week getting to know yourselves of the Jupyter Notebook environment and understanding like these different things of edit mode and command mode. But I won't be spending lots of time on this because these are things. So my focus is to spend time on things that you could actually be stuck at when you go back and you're reading this chapter. But I feel like these are things that you can learn at your own pace. So now we're getting into the meat of the chapter. So let's look at what is machine learning. Cool. So this is the key bit. This is what we're all here for. We're all here to learn machine learning and deep learning. Somebody asked, like, do I need to know machine learning to be able to start with deep learning? Well, deep learning is just a modern area in the general discipline of machine learning. So machine learning is this whole broader thing. Like you have all these different, like this whole practice is called as machine learning, and deep learning is just a modern way of doing these things. Like neural networks and all this stuff that we call deep learning is just actually a part and a modern way of doing things using machine learning. But in this section, let's see what machine learning is. Something that the book says is machine learning is like regular programming, and it's a way to get computers to complete a specific task. So in your heads, I don't want you to think of machine learning as, oh, it's something that's so complex, it's something that's so different from regular programming. It's actually not, if you think of it. For those of you that have tried machine learning, or for those of you that are new to machine learning, it's only a set of code and it's only a set of instructions that you run and you complete your task. So if your task is prediction, you actually create a program that then learns how to do those predictions. So it's not very different from general and regular programming. So something that this point forward that goes is like machine learning, if you think, it's still like a little bit different in the sense that when you go, like when you're trying to do, say, the main difference that I find is like when you're trying to do, say, build a website, or you're a web developer, or you're trying to do software testing, then something that you do is, okay, I'm trying to do this particular thing. Then what you do is, okay, I think of these tasks. Like the first thing I need to do is write a test for this function that can 1 + 1 = 2. The second thing that I need to do is be able to run this test. The third thing I need to be able to do is create another test, or whatever. Like there's this set of steps that you have. In machine learning, it's not generally like that. Like you don't have like this. When you're creating a model, you're actually getting to a point where you teach the model to learn itself. But we'll get into the details of it very quickly. Like there's more on this, so if it's okay if you don't get this part, but bear with me. So a deep learning or a machine learning or a general program in that manner can be thought of like this. So if you haven't, say, when you want to, like a general program, if you want to go from an unsorted list to a sorted list, then what do? Your inputs is an unsorted list. By unsorted list, what I mean is something like 1, 9, 2, 4, something like that. Like it's unsorted, and you want to sort it to something like 1, 2, 4, 9. Then a general program is nothing but you get some inputs, then the program does its thing, and you get a result, which is the sorted sequence. So this is what general programming is. But Arthur Samuel basically in 1949, he was a researcher at IBM. He thought, okay, maybe there's a different way to get computers to do things. And that different way is what is called machine learning. So he thought, oh, maybe there's a different way of like, I don't have to write the program. I don't have to define the steps for the program to actually go from an unsorted list to a sorted list. But actually, there's a way that the program can learn on its own, and that's what is machine learning. So instead of telling the computer the exact steps required to solve a problem, show it examples of the problem to solve and let it figure out on itself. That's the key bit. Like that's the key difference. It's like we're gonna let the computer figure it out on its own. It's like a baby that when you teach, like a baby learns from its environment. Like the baby sees 100,000 different examples of like using a spoon to eat food, and then you don't actually give a set of steps to the baby. You don't say, okay, you hold a spoon and then you pick it up by this and then you put it in your mouth. There's no set of steps. It's actually like the baby learns by looking at examples from adults around. And this is machine learning in a way is very similar. Like it learns from examples. So that's the main thing. Like that's the one thing that you should be very careful of, like when you're thinking of machine learning. One thing that he did say one thing that he did say is, here's how he described his idea of machine learning, is like this. Suppose we arrange for some automatic means of testing the effectiveness of any current weight assignment in terms of actual performance, and provide a mechanism for altering the weight assignment so as to maximize the performance. We need not go into the details of such a procedure to see that it could be made entirely automatic, and to see that a machine so programmed would learn from its experience. So in this text, Arthur Samuel was actually trying to describe what machine learning means in his own mind. And there's lots of powerful concepts in just this amount of text. So what he's saying is basically there's something called weight assessment. Like he said, what is weight assessment? He's mentioned something like actual performance. He's mentioned something like automatic means of testing. He's mentioned something of a need of a mechanism. But what do these things actually mean? So now let's spend time, and we're going to dive, as we say, deeper and deeper into these things of like what exactly is weight assignment, what exactly does he mean by actual performance. And what he means by weight assignment is something like this. So remember how I told you you have an input that's an unsorted list. It goes into the program and then it gives its results. So we had something like this: an input, program, and results. The way he summarized this is that instead of calling this a program, let's call it a model, and let's say it has some weights. So you have your inputs, which go into the model, and the model also has some weights, and then you get some results. So let's think of it this way. And these weights, think of these weights as like levers, or think of these weights as basically just things that can alter the results. So if the weights are different, the result from the model is going to be different, even if it's the same input. So think of these weights as things that control the model. So we've changed the name of a box from program to model. This is only to follow the modern terminology. Like there's no difference in Arthur Samuel's way of thinking of what a program is, but we just call these things as deep learning models today. And that's why we've just called it model, and that's why we've just called it weights. We could have even called it parameters. So that's the next thing. So this is just what he meant by weight assignment. So, that's the first thing. Like he said, this idea of weight assignment, which is just this, that something has some weights that can then be changed to alter the results. So that's a weight assignment. Next thing that he says is like, what we need is an automatic means of testing the effectiveness. So this can be summarized by this image, this idea of having it can be summarized like this. So right now we saw a model has some inputs, which is here. A model has some weights, and based on that, it gives results, right? But if you think of it, what machine learning does today is like it learns from examples, and if you have like it's different from general programming. Is like if you want to teach computers to learn by themselves, then you need to give computers a way to be able to update those weights. Because something I've mentioned so far is like if the weights are different, the results are going to be different based on the inputs, right? So think of it like this: if you have an unsorted list, like 1942, and I have some weights W, and based on this, it gives me an output like 1924. But this is incorrect, right? This is, we know that this is these weights, whatever these weights may be, without telling you what weights are, based on these weights, the output is incorrect. So something that we want to do is we want to be able to alter these weights so it gets to a point where it goes, okay, well, now that my weights are updated, so I'm just going to call them WU, updated weights. And based on this, it gives me the output of 1249. So that's what this idea is. But how does a computer know how to update the weights? This is the idea. You have your inputs, you have your weights to the model, you get some results. Based on that, you calculate the performance. Basically, what that means is you calculate how right or how wrong your model is, or whether it's performing based on your expectation. If the performance is low, then you update the weights until to a point that the performance is high. So that's the main idea. Like this is the main idea of having an automatic means of testing the effectiveness. So once this model, so as I said, you have this unsorted list, you have some weights updated, and you have a sorted list, right? These weights are updated and my performance is high. Then I could also provide this with a different sequence. And I could use the same weights because right by now the model knows how to sort things, and it will sort a different sequence. So we've gone from a model that didn't know how to sort things to a model that now does know how to sort things. And this is what is called that the model is trained. So when we say that I have a trained model, that just basically means that it knows how to do the task that I'm trying to teach the model to do the task. And this is what it means that it's my favorite weight assignment. Basically, these weights are the perfect weights for me to be able to solve this task. And that's why this weight assignment is good. So by the end, when you have this model, it just behaves like this, right? You can provide it with any inputs, like I have 2953. You have any model, and then it will give you these results, right? So it's by this time, a trained model is just like a computer program, right? We started with the definition of computer program right at the top, that a computer program is a set of steps that when you give it an input, it runs that program and it gives you these results. This is what a trained deep learning model looks like, right? Once it's trained, you give it some inputs, the model does its thing, and you get some results. So this is an important insight. A trained model can be treated just like a regular computer program. So those are the that's what generally machine learning is. That's what generally you mean by, I mean, this is just all very generic, and we haven't really gone into the details of it yet, but this is what generally means, like this is what generally the concept of performance means. This is what generally the concept of model training means. What model training means is we're updating the weights of the model to the point that it can actually do the task that we want it to do. Now what we're going to do is we're going to spend time in looking at what is a neural network. We're going to go into the deep learning jargon. And finally, what I did was I missed this bit. This is where we train our first deep learning model. So all I do this. I just press shift enter, and there we go. The model is training. So it looks a lot like this. That thing that we're doing at the top that looks a lot like this. We're giving the model, like the model has some weights. We're giving the model some inputs. in turn, the model gives us some results. We calculate the performance of that model, and we update the model weights. We keep doing this over and over and over and over and over again until the point that we get our favorite weight assignment and we're happy with the weights. And then we know that this model is able to do the thing that we want it to do. So let's have a look. So that's the first thing, right? The error rate is something, it's like that's how we calculate the performance. So let me actually quickly take this. And paste this here. So just so you guys understand exactly like some idea of what it means by model training, and you guys understand of some idea of what we're doing. We're following this exact same process. We have a model, which is, we just created this model. It's called a learner in this case. So a model is just a learner. And we say, okay, model, you start to train. It's seeing some inputs. These inputs are coming from here. There's just pet images, and this model has some weights. It gives us some results. By results, I mean, it's giving us an error rate of 0.009%. So it's actually really good. And we're checking the performance of it, and we're updating the weights. So the first time it had an error rate of this, but because we're doing this task over and over again, and we're updating the weights to the point that its performance gets better, the second time we have an error rate of 0.004. So that's the main things. Let me quickly check if there's been lots of questions. Oh, how would I handle inputs with variable lengths? I think that's a good question, but it's still, you can still pass inputs to the same model and we'll still do things. Like this sorting of an list was just an example. Cool. Let's get into this idea of, like, you would have heard this word. I'm just conscious of time because I said 60 minutes and we're already at 51. We just trained our first model and we haven't really gotten to the point where I thought we could. But let me just quickly spend some time and on going forward with this chapter. And then after that, I'll answer all the questions. So what is a neural network? I mean, this is a word that most of you, if not all of you, would have heard in your lifetime, is like a neural network. And then what exactly is it? Like, how do I even define something like a neural network? Well, a neural network is nothing but a function, like you can define mathematically as a function that can be used to solve any given problem. So right now, what I mean by that is, like, if neural network is a function that can be used to solve any problem, the neural network can be used to solve the sorting of the list problem. A neural network can be used to classify pets and images, like it can be used to classify dogs from cats. A neural network can be used to predict the next words of a sentence. A neural network can be used to classify X-ray images. A neural network can be used to classify CT scans, or it can be used to solve pretty much any problem that you think. So a neural network, what is it? It's just a mathematical function that is capable of solving any problem. And this is called something like the uniform, I think it was called uniform solution, something like that. But what we need, so we've looked at this, like this model, if it's a neural network, then the one thing that we need is we need this way to be able to update the weights of this model, right? And that's something, like one could imagine that we need a new way or find a mechanism for automatically updating the weights of every problem. So the question is, like, if a neural network is something that can be used to solve any problem, then something you might ask, okay, if we're trying to do image classification, then do I need to update the weights of my model? Like, is it a different algorithm, or is it a different way to update the weights of my model? Or if I'm trying to do CT scans, is that a different way of updating the models? Or if I'm trying to do text classification, then is that a different way of trying to update that my model? Actually, the answer is no. So what we need by now, like if everything was a different way, then what we need is we need one way. We need a conventional, we need a generic way that we can update the weights of the model. And that generic thing is called stochastic gradient descent. So this idea of being able to update the weights. So this model, if it's a neural network, it can be used for any task. But this update point of being able to update the weights, no matter what the task, and being able to still achieve good performance, this idea of being able to update the weights of this model is called a stochastic gradient descent. So right now, in the first chapter, we pretty much have spent much time just understanding just these basic concepts of like what is a deep learning model, or what is machine learning, or what is performance, or what is stochastic gradient descent. So this is just sort of laying the groundwork of what's coming in the next weeks. I think we're out of time, like it's just 5 minutes left. I will stop here today, but what you will do in going back is you'll take this of what we've learned so far of 1.6.7, go back, make sure that you have a GPU running, and make sure that you read every point of line of the book to this point. And we're going to pick up things from here after that. One thing I do want to, I've already said that deep learning models are not just for image classification. Like the one example that we saw of that code was actually doing pets, but actually deep learning can be used for a lot of other things. So it can actually be used for something like segmentation. And what segmentation means is it looks like this. When you're doing self-driving cars, then if you see an environment, then you need to be able to classify a bicycle from the road. And these are all these things that we're going to be learning over time. It can also do things like text classification. It can also do other things like audio classification. It can also do things like time series analysis. It can also do things like fraud detection. So there's all these different tasks that deep learning can do. And over time, we're going to be spending time learning all of this. But go back and spend some time just reading so far. And let me just go have a look at the questions that we have. I must say one thing though. I thought that we will be able to make more progress than imagined. But something I've realized is it's going to take more time. So I think this is open for discussion, and this is something let's discuss if you guys have time. Let's see if we can increase the time from 60 minutes to 90 minutes. And this is an open question, but feel free to reply in the chat, or let me just put this comment here. And you can feel free to reply with a yes or no if that's something that will suit you. So the difference between several use cases of universal approximation, that's what it's called. Yeah, universal approximation theorem is the SGD. So the difference between several use cases, that's correct. Pretty much. We'll go deeper into this. Like I haven't been able to touch and cover as much ground as I wanted to, but we'll touch base into exactly what universal approximation function is and go deeper into what SGD does. Although I've read SGD and backpropagation, I still don't understand how they are related. Okay, that's okay. This is one thing I can quickly look at and help you with. So backpropagation basically means, and this is something it's okay for anybody else if you don't understand, but backpropagation basically means that you have your you start with your input, right? You have your model and you get your results. This of going in this direction is called a forward pass. Then you calculate the performance, and then you go back and you update the weights. So this process of going back into the model and updating the weights is called backpropagation. And the theorem, or the thing that's responsible for updating the weights in the correct manner that your performance goes up, is stochastic gradient descent. So stochastic gradient descent is the method by which you update the weights of the model. But the process of updating the weights of the model is called backpropagation. If anyone needs any help with setup, please let me know. Thanks, Sam. Why do we do fine tune? Okay, this is something I did want to cover. I didn't get enough chance, so let's leave this as something that we cover next week or over the week. I would also appreciate if it started 1 hour later. Oh, everybody's saying yes. Awesome. Cool. So let's do this. So let's increase next week. Let's go and make it 90 minutes. Oh, now I'm getting greedy, but how about 120 minutes? This is just a question. Like, I'll be investing lots of my time, but would 120 minutes be a lot of time? Okay, a lot of people are saying 90 minutes, so that's fine. We'll stick with 90 minutes. But go back today. Your homework for the time being and what you have to do over this week is go back and make sure there's a Fastbook. If you search Fastbook, it opens up this thing called a GitHub repository. Make sure that you go to these setup instructions, which are mentioned here. I've already shared this with the group, but I'll be sending a message on the Slack. So one thing you do want to do is come here and join this weights and biases Slack, or I'll also, so basically join here and I'll be sharing the set of steps and everything that you have to do for this whole week. And we'll be discussing lots of things over this 1 week. But make sure that the one thing I really want to stress upon is make sure that you go back and you have your system running, because every week this is going to go, this is going to become increasingly difficult. So if you, and we're going to run more and more code. So we want to be set up and we want to be ready. And then once you have your setup ready, so have a look at this video from Jeremy Howard, which is the introduction, and it shares how to do setup. So that's the first step. The second step is then you go and you actually try and run this notebook, and you actually read this notebook to the point of 1.6.7 is where we left. So next week when we come back, I will come back and we will look at this, and we will read from 1.6.7 from here on. And if you have any questions, head over to this point, 1db.me/fc, and you go to forums. You could also start a discussion here. If you have anything that's not already mentioned, you could start a discussion and you could just say, hey, I have a new question. And you could ask your question here, and then we as a group will try and find this. Cool. With that being said, thanks everybody. Please, I'm going to be still around for questions on Slack and weights and biases forums, or even forums at Faster AI. But please do ask your questions. Thanks for coming.